So let's get to the least common multiple known as LCM. Right. So when we talk about LCM, first let's understand what we mean by the multiple part, right? Sorry. So the multiples are basically, if I'm talking about the multiples of 4, that's like 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 24, 28, and so on are the multiples of 4. Let's talk about the multiples of 12. 12 ones are 12, 12 twos are 24, 12 threes are 36, and so on. And if I'm talking about, let's say, 20, right? 21s are 20, 22s are 40, 23 are 60, 24 are 80, and so on. So let me try to find the LCM of all three, right? So if I keep writing it, I see 20 here. At some point, I'll see 40. At some point, I'll see 60 and 80 as well as multiples of 4, which is what I'm seeing here for 20, right? And then if I'm talking about this, 36, 12 4 are 48, 12 5 are 60, and so on, right? So what are the common? First I see 20 and 20, but I'm not seeing the 20 in this list. Then 40 and 40 I'm not seeing again here. 60, yes, I'm seeing. Sorry. And 60 I'm seeing here. And 60 I'm seeing here, right? So that's like the common, and that's the smallest. If I keep writing, I'll get 120 here and 120 here as well and 120 here as well. 26 are 120, 12 10s are 120, 4 30s are 120. That is also a common multiple. Like 240 is also a common multiple for all three, but LCM is basically the least, right? So that's fundamentally 60, 60, and 60 is the least. So LCM is 60 for 4, 12, and 20. Again, how do you calculate LCM for numbers? Two ways, like how we have seen, right? One is fundamentally the prime factorization way again. Right, let's talk about 4. That's 2 into 2. That's 2 square. 12. 2 into 6, 2 into 3, that's basically 2 power 2 into 3 power 1. And 20 is 2 into 10, 2 into 5, sorry, 2 into, 5. So that's basically 2 power 2 into 5 power 1, right? So how do we do for LCM? For all three, I'll first look at the prime number 2, which is common. Now, instead of taking the smallest, which we have taken, right, the powers wise, the smallest in HCF, I'll take the largest, which is fundamentally 2 power 2 here for all three, luckily. Then I'll see 3, right? Here I'm not seeing 3, I'm not seeing 3. So that's indirectly basically 3 power 0 is 1. I can also write this as 3 power 0 because 1 and 1. So fundamentally, if you are not seeing a number, that means the power is 0 for them. So I'll take the highest power, 3 for 3, that's 3 power 1. And then for 5, 5 power 0, 5 power 0, and I see 5 power 1 here. So that's the highest one. So that is basically 4 2 square into 3 into 5. That's basically 12 5 is 60 is what the LCM is, right? Which is what we've got in the previous one also. And the other way is, second approach, which we would have done in school, is writing the numbers like this: 4, 12, and 60. Now I'll try to take a common prime number which can divide all of this, a factor or a divisor basically. 4 is not a prime number, but so let's do with 2 if you want. 30. We can also do with 3 and 15, right? Now I can't divide any with any other number 1, but if you have multiple numbers, the logic is, if I can write any prime number here which can divide two of this, even that is a good enough one for us. So I won't touch the 1, but 3 ones are 3 and 3 fives are. Now I stop it here because I can't divide further. So it's fundamentally 2 into 2 into 3 into 5. That's again 60 basically, right? This other way that you do to find the LCM, right? So couple of other properties which would help us solve few problems. So if you want trying to find the HCF of fractions, so that's basically HCF of numerators by LCM of denominators, right? Let's say I'm trying to find for 1 by 2 and 1 by 4 HCF. So what is HCF of numerators is 1 comma 1. HCF is 1 itself, and LCM of 2 comma 4 is 2, so that's why it's 1 by 2, right? So 1 by 2 comma 1 by 4, the HCF and LCM as this. So if I'm trying to find the LCM of M, 1 by 2 and 1 by 4, the LCM, first I'll take the LCM of the numerator. So that's again 1 comma 1 is 1, and HCF of denominator is 2 comma 4, is highest common factor is again 2, right? For these two. So if I'm talking about so LCM of 1 by 2 comma 1 by 4 is LCM of 1 comma 1, which is 1. That's a common multiple, the least common multiple. And HCF of 2 comma 4 is 2, which is the largest one that can divide both. And something similar for here as well. So 1 by 2 and 1 by 4. So HCF is 1 for the numerator, and LCM of denominators is 2 comma 4. LCM of 2 and 4 is fundamentally again the least common multiple is 2, which can divide both. Right, so I know other properties HCF of two numbers into LCM of two numbers is basically product of these two numbers, right? So that's like HCF into LCM of those two numbers should be fundamentally the product of those two numbers. So we're talking about HCF of two numbers is 72 and LCM of these two numbers is 12. If one of the number is 24, find the other number. Right? If you remember that we have seen the property HCF of two numbers into LCM of two numbers is basically the product of the two numbers. So 72 is HCF of two numbers, 12 is the LCM. I know that one of the number is 24. Let me find the other number, right? 12 2s are 236 are. So the other number is, so that means the other number is 36, right? So this is the property which would help you to solve problems like this.